Hi everyone. So in the last tutorial, the third video, we finished the player script, and if we hit play now, um, we can fly around, camera follows us, the engine particles are working really cool, things are working. But what we were missing was the feeling of outer space around our player. There's no stars or anything, there's nothing around our player to gauge any parallax of the speed of things passing by, so we can't gauge our own player's speed. So this tutorial is just going to be about writing up a script and setting up an object to create some stars in our universe. So in our player cam, here, I'm just going to go game object, create other, particle system. I'm going to hit this little gear here and do reset and make sure it's zeroed out. Okay. And in actuality, let's zero out the camera with it. Because the camera is going to get moved to its position anyway. But what we can do is pull that in there, and then let's just move the camera back to where we had it, somewhat like where we had it. So what I'm going to do is I'm going to call this Starfield, okay? And we're going to go in our scripts folder, and we're going to create a new C# script called, how original, Starfield. And basically what we're going to do is we're going to control the particles for our stars with the script. So in the default particle system, we can turn off looping, we can turn off play on awake, we can turn off emission, shape, basically everything but the renderer itself for the particles. And for our stars right now, I'm just going to use this default little tiny sphere thing. So let's just apply this Starfield script and double click it to open it up. And this script is going to be actually a lot simpler than some of the other ones we were working on that took like 30 or 40 minutes to write the script. This script's pretty short. So here we go. We have a new public class, Starfield. It's going to control it. So the first thing we're going to have is a private variable. Remember, arg, I use Unity script too, so sometimes it's just a habit to type in the whole var thing. So we're going to have a private variable, and again, we're going to call it this transform. And you probably know from the earlier videos, this is really going to stick in your head, that this is a variable we don't want to see in the inspector, so it's private. It's a transform type, and it's going to be this transform of the Starfield thing. And basically, we're going to go in our start method here, and we're going to say this transform equals transform, right? We did it again. So caching the transform for this object up front. So the update function or any other function that's called many times over and over and over during your game is not looking for this transform up constantly. So we've cached the transform, we're good with that. The next variable will be another private variable called particle system. You've seen this one before. The particle points. Okay, and then we're going to go down, and if you're curious about this, oops, arg. So if you couldn't tell by looking at that, the two little, I'm uploading a lot of stuff, so Okay, I'm going to get out of here. It's lagging and everything a tremendous amount. So this is an array of particles. That's why you have these little brackets here. It's showing you that this is multiple. We're not going to mess with that or adjust that or anything. That's just a private variable it's going to gather on its own. So those are the two private things we're not accessing. The system will take care of those. That's an access to the particle system itself and its points up here. We're not messing with it. So our first one that we're probably going to mess with and adjust is going to be a public integer, and it's going to be called stars max, and then we'll set it to a value of 100. We're not going to put an F for float behind it because this is actually a real count, an integer, a whole number, 1, 2, 3, 4, 5, no decimal points here. This is actually going to represent how many stars we actually have in the world around our player. The next one we have is a public float, and this is a float, and it's going to control the star's size. So by default we'll start with a scale of 1, and we can scale them down and make them tinier if we want. The next variable will be a public float, so a floating decimal point number, and this one will be called star distance. Okay, you can guess what that means. That's basically the kind of the offset away from the player that the stars are going to be. So the next variable is another public float, star clip distance. And we'll just give it a distance of 1. That's basically how far out away from the player that it's going to start kind of culling off the particles. We're not going to draw any other particles that far away from the player. It's good optimizing technique. I'm going to separate these because this is another private variable and it's a float. Star distance square. And the last variable is another float, star clip distance square. And those are both square what they're going to do is they represent square magnitude values for determining distances. So those are going to be used in calculations within the script that we don't really need to figure any of the math out. It's going to do that for us. Okay, so we've cached our transform and start. That's all of our variables here. We can do not touch internal math stuff. That's what I like to say. Star, and speaking of that, star distance, oh no, star clip distance square equals star clip distance times star clip distance. Okay, so it's a squaring of that. Okay, I get it. So that's how we're getting our star clip distance square. We're just multiplying the star clip distance by the star clip distance. Boy, I'm like in high school mathematics again. Okay, so we're going to create a private function called create stars. And it's private because we're not going to have anyone accessing this from outside of this script or changing any values or anything like that or thinking up something silly like that. Okay. Oops. Sorry. We got to fill in that array. Golly. Okay. So that's what these funny looking brackets were here. That's an array. So instead of saying up here this is just one particle system, we're saying like, well, it is one particle system in the beginning here. And then the particles, which are made up of points in it, are a bunch. So there's more than one. It's not just one point. So it's an array. And in here we're just saying, all right, well, this variable points is going to be an array of points inside of this, an array of these different particles inside this particle system. And we're going to go, it equals a new particle system, stars max. So basically your star max is how you're going to populate all these points of stars in this particle system dynamically. So now what we need to do is a for loop, which is basically we need to go through and loop through all of the points between 0 and the stars max, and basically set their position, set their color, and set their size, all of those. So a for loop is something, we'll type some of this out and then I'll explain it better here in a second. It'll make sense, I swear. Then we need brackets, so we're going to do something inside this for loop. Okay, I'll explain this here very momentarily, kind of the best way I know how. I am not the world's best programmer by far. I come from an art background, so I was an environment artist on quite a few games, and never professionally a programmer, but Unity caused me to kind of take programming up to make my own games, and I learned by trial and error. I'm copy and pasting some of this so I don't have to retype all of it. So we've set their position. Color equals new color 1, 1, 1, color 1. I'll explain all of this here shortly, as soon as I type it out. Size equals, okay, star size. Alright, let's fill some of these gaps, these big nasty gaps I made in our script. Okay, hit Control S to save. So, okay, create stars. So we're saying the points are basically all of the particles in this particle system that are going to emit, and it's stars max that you set up here, this integer. So we set 100. So the points are going to equal 100. Then we say, alright, let's do a for loop, which means since it's an array, it's more than one object, which means we need to look for all of the objects up to the amount that this is set. Okay, so what it's saying is for. So while we're looking, we set a temporary variable called I, which is an integer. Okay, we set it to 0. We say while I is less than stars max, which is the 100. So while it's less, let's continue doing this. And then after that it says let's add 1 to I plus plus is just I plus 1. So it just keeps adding to it. While it's less, add 1. While it's less, add 1. And what happens is the for loop breaks out when this is finally not true. When I is actually equal to stars max or greater than, it stops. So this is a way to kind of cycle through stars max. Really, it's the ability for it to find all the points. That's why we have this little thing here. It says points I. So we're saying I is that temporary variable. I really represents each point that we're finding, each individual point. Okay, and while each individual point is less than 100, or whatever you set stars max to, keep incrementing. Stop incrementing and stop looking for points when it's no longer less than. Okay? So we say for each point that we find, points I, for every single one we find, let's set a position on it, and we'll make that position random, which does what it says, randomly inside unit sphere. Okay, and inside unit sphere is not something I made up. It's actually something quite a few people use in Unity to generate things inside of a sphere. We'll pop this open. Returns a random point inside a sphere with a radius of 1. So really, a lot of people use this to spawn players and all kinds of different things. It's a default radius of 1, but you can multiply it over here and make that sphere radius like bigger than 1, 5 times bigger. Okay, and it just finds a random point inside. Okay, so we're saying the position is a random point inside this unit sphere. times the star distance. So it's telling us that the sphere can be up to 10 units big, 10 times 1. And then we're going to add, sorry, I don't know why I typed TX position, typo. We're going to add this transform's position onto it. So the distance plus the position of where our player is. So based on where the player is. So just generate all these points, the 100 points we want of particles, inside this sphere that's the distance away from the position of the player. Then take each one of these individual points and set the color. This is the color attribute on the particle to a new color, which for color, it's kind of cool. Maybe I'm uploading like 6 gigs worth of YouTube upload videos here, so things are kind of going a little slow here on the internet. So here we go. This is like the color, and sometimes it's just written out like this, like color black, but it can also be written out in the longhand way, which is this, which is how our script has it written out. So like what this would be, 0, 0, 0, and 1 would be red, green, blue, and alpha. Full, let's see, 0 is transparent, and 1 is no alpha, and 0 is full alpha. Yes, I'm pretty certain. Okay, red, green, blue, so 0, 0, 0, 0. If you want blue, no red, no green, all blue, no transparency. So you get what's going on here. We're saying, okay, the new color for each one of these little particles is going to be just white, or full red, full green, full blue, no transparency. So we're just leaving them the white. If you want to color them a little bit, then just go in here and look in here, and you can actually just go and it'll tell you the values too right here, where they are for gray, or whatever other color you would want your stars to be. Just use the documentation and look in there. And then of course each one of their little particles point size is going to be equal to star size, which is going to allow us to adjust this in the inspector. Basically tell our particles, well, let me move my recording software crud. I have like a couple of monitors here, so that's it. That's our create stars function. And we're going to call it from inside of update, okay, just like we did some of our other scripts. So this is the last function we need to fill up here. It's got about 10 lines of code, and then we're done with this starfield script. So we're going to do another one of those sanity checks that we've been doing, and I guess that point is really getting nailed home. And it was a new thing for me. Maybe a year ago I was decently scripting, but I never did these kind of checks to make sure something wasn't null or missing, and those are the kind of things that can lock your game up. So all we're saying in update, if points are null, if there are no points, then run. And this is kind of unique, because normally we're saying don't do something if it's null. But what we're saying is if the points are null, which means no points have been created yet. And remember, this is private. We don't create the points. The points actually should be populated from the particle system itself. And we're saying, well, if they're null, which means they're not there, then create them. And that's what we do. We run up here to create stars, and we create them. Okay? That's spectacular. So once it starts creating them, in update, we're going to do another for loop, which means we're going to go through some values. Int I equals 0. I is less than stars max I plus plus. Now the I plus plus part is really important, because we're asking this, if I is less than stars max, then continue running this for loop. If we weren't incrementing here and we didn't have this adding 1 to I every time it counted, we would actually never be equal to stars max, because it would never increment. Therefore, we would be permanently stuck in this loop. And that is not good for the game. So what we're going to do in here, and I'll explain this in a minute, not equal to, minus this transform dot position dot square magnitude is greater than star distance square. Okay. You know what? I just realized my scripting stuff was tiny for you guys. I'm sorry. Let's make it big. Points I. Nope. Brackets. Brackets for an array for multiple points. Points I date position equals random. And we're gonna just copy this inside unit sphere dot normalized times star distance plus this transform dot. Looks very familiar to what we were writing up in create stars, except what's happening is these little star points and everything on the particle effect, they go away. They have a lifespan. So what's happening in update is we have to continually keep going through all the stars that we have and keep checking their position minus the position that we're at now, the magnitude of the distance there. And then we got to keep offsetting and positioning each one of these points' position inside this unit sphere and normalize it, which means it's a normalized value times star distance plus the position where it is. So, and then we have another if, another case, if points I position minus this transform position. That's not how square magnitude is spelled. Square magnitude is less than or equal. So the earlier issue is asking if any of our points position what square magnitude was greater than the square of the star distance. This one's asking if it's less than the star clip distance square. Okay, so another if, another question here. If it's less than or equal to, we're going to go in and we're going to set a temporary variable in here, a percent variable, which is also a float, and we're going to say it's equal to points, one of these little individual points in the entire group, dot position, minus this transform position, dot, me and misspelling the square magnitude, divided by the star clip, spelling errors. Okay, and what we're going to do up here, we're going to take the color and the size and we're going to paste it again, and we're just going to say, and this was going to help us make the color fade out, the alpha actually, not the color. So this is going to say for each one of these points their position based on where our position is, the square magnitude of that. If it's if the percentage is going to be a division of that and the star clip distance, we're going to say each one of those points colors that the alpha on it is going to be this percentage. So the percentage is going to be continuously deducting based on where that particle point is and our transform position, the magnitude of that distance. So in layman's terms, what it's going to do is when the point gets the certain distance away, a certain percentage, which is calculated right here, it's going to fade out by that percent, which that percent's going to keep getting smaller and smaller because this is the particle's position minus where the player is. Okay, so it's going to keep getting smaller and smaller. And this size is going to be the percentage, I forgot that part, times star size. So we're also going to say don't just fade the alpha out on this particle, but make the stars appear like they're going further in the distance by scaling down each one of the little stars' size by this percentage. And it's not percentage, it's percent. So this is the calculation for each little point's position based on the distance from the player. And then we're saying based on that distance, fade the alpha, make the size smaller. That's pretty cool, right? Pretty smart. And then out of each of these ifs, so the first if is saying if that star is within a decent range of the player, then you'll do that. And if it starts moving farther away from the player beyond the star click distance, then start doing the fade and the size scaling. And then outside of all the ifs, let's take our particle system, set particles, points dot length, and then remove our empty spaces because we got them. Okay, and then particle system set particles. It's pretty cool. I'll show you that. It sets the particles of this particle system, and the size is the number of the particles that is set. Okay, so it's basically just saying the points, basically all the points, the length, and length is, we'll look that up. You could probably guess what that might be. There we go. It is the length of an array, so it's the amount of items in an array. And remember when I said up here that this points was an array because of these two brackets? Well, it is. It's an array of little particles. So all we're doing is setting that. We're setting the points by the length of whatever's left in the array currently at that moment. Okay, so we hit save, and we go back to Unity, and hope I don't have any errors, and I do. I'm missing a bracket somewhere, I'm sure. Let's see. Oh, oops. I used a system type there, and I didn't use my, where's my variables? Particle system variable. Okay, we'll wait for it to sync up. Okay, so what we have now is the star field, and it's a child of our player camera. And the script's applied. And we have the stars set to 100. We have their size set to 1, distance to 20. So we can just hit play, and we'll see how this goes. Well, that don't look right. And first off, okay. Let's turn them back on. Oh, wow. What in good tarnation is going on? Alright, something. Let's turn off looping. Let's turn off emission. Something went wrong with our objects. Okay. So we're also not rendering them, which is weird. Are we culling anything out? We should see them. Where's the player camera? Oh. Hmm. Well, let's hit some gas and see if we see any particles. Let's go over here to our player. That's odd. We'll have to troubleshoot this here for a moment. Okay, there they are working. But they keep moving farther and farther in front of the player. That's weird. Let's move them actually into the player. No, that's not proper. That's really weird. They're, wait. Simulation. Oh, that I think was it. The simulation space was set to local and not world, and we need them to be in the world. I think that was it, dang it. Okay, yeah, it's functioning now. The only problem is I'm not seeing them. Alright, where's the camera? I should be seeing them. Let's, in local. Okay, I think I know what the problem is here. So there's our camera. The star field's right on the camera. Let's move it forward and see what we get. Alright, that's much better. But that's still not great. Probably has to do with let's make them go forward like that. Let's change some of the values here. So let's say we have 150 stars. I don't want their size so big, so let's go a lot smaller. Let's set their distances way out. Okay, alright. And we don't want them to get too close to the player, so let's clip them like 5. We don't want the stars right on top of the player's ship. We want them to look sort of like they're off in the distance. They're still too close to the player, so let's do that. Set them a little closer, a little smaller size, and particles batch. So even on mobile, you're going to have like 200 like that. Alright, now that looks like there's a bunch of stars around. Wonder if we can tweak this value, and no, we probably can't. I'll set them farther out. It takes just an eye of tweaking. Let's go through. Okay, so what I'm going to do is I'm going to pause it. I'm going to go by, and what you'll see occurring here, I'm going to hide the grid. What you'll see occurring here, I'll hide the skybox too, is there's just a bunch of stars only around the player. So, but when the player's flying through, it just looks infinite. You know, it looks like there's stars like everywhere. And we could also, just for fun, let's just double up the amount of stars. And that's still not so bad. And then, we'll give it some gas. Let's see how fast we get going. And that's great. It really gives you a sense of the speed. I'm going to try to set a distance farther out to make the stars look like they're farther away. I don't honestly like it when they look like they're right on top of the player. That's cool. I like that effect. It's pretty cool. And as we slow down, the particles simulation slows down too. I'm going to see if when I adjust this in real time, yeah. Oh, okay, it was looping through the array and I went and was swapping it out while it was going through everything. That's pretty cool. Now it really adds a sense of speed and rushing through, you know. I feel like we're really moving fast through it now. But I'm not going to ramble on forever on this. That's basically oops. That's basically how that works. Now I can't see the stars at all. And also, I think it's just really important to have these stars like somewhere where the camera actually gets the bulk of them. You know, where the camera can see most of them. And that's pretty cool. So as you can see, let's bring the skybox back. You can see it's just generating stars around our local player. That's pretty awesome. But this tutorial turned into a 40-minute almost deal too. Anyway, so that is the generation of our star field around our player. So pretty cool. Really gives you the feeling of like flying through space. Okay, so the next tutorial, the next video tutorial I'm going to do here will be shooting projectiles, and I think just for starters we're going to shoot projectiles at asteroids, and we're just going to give the asteroids health, and we're going to destroy them. And then as we go further along in videos and get more complex, we will use that health we set up for destroying asteroids and stuff like that for actual enemy ships, AI enemy. And we're going to go the whole gamut of patrolling waypoints and visual sighting of the player and seeking the player and chasing them and firing at the player and then the player being able to be destroyed. So you know, it's a work in progress in a series of videos as I get there. So I hope you enjoyed this one and it'll help you set up Starfield for your games. So I'll see you in the next video.